Hello everyone. Welcome to 360DigiTMG Domain Analytics program. So today we will be discussing about banking and insurance domain. Since we have covered a few domains like healthcare analytics, and we have covered the trade analytics, various analytics that we have covered. If you want to go through it, in that case, you can simply search 360DigiTMG on YouTube, and it will lead you to 360 page. In that you will be having the playlist. From there, you can able to access all the domain, all the domains that we have covered till now. So we have already covered the banking and insurance analytics previously, and now we are combining both. So whatever the applications will be having when it comes to both banking and insurance analytics, and where exactly we'll be using this, machine learning especially. So machine learning, where exactly we'll be using when it comes to banking or when it comes to insurance. So what are those applications and how can we improve the banking and insurance analytics? So all those things we'll go through one by one. So what is the need of machine learning? So what exactly the machine learning is, and what is the need of machine learning, and why there is so much buzz regarding the machine learning nowadays? So all those things also we'll try to cover in this session. Before that, we'll go through what exactly the agenda of this session. So agenda of this session, this whole 16 hours domain analytics program is applications. First session we will be discussing about what exactly the machine learning is and where we will be applying with respect to that domain. So since we are covering the banking and insurance, so what are the applications we'll be having in banking and insurance, and what are those applications? We will be taking a few use cases and we'll try to understand those, and then we'll be having the CRISP-ML methodology. So it is the second module we will be discussing. In that, what exactly is the CRISP-ML? So why do we need that CRISP-ML? Why do we need to follow this? That CRISP-ML format? What is the CRISP-ML format is cross-industry standard process machine learning quality assurance. CRISP-ML means cross-industry standard process machine learning and quality assurance. Why do we need to follow that? See, if you are doing any project, especially when it comes to data science, so whenever you are doing some kind of project, in that case we will be following one hierarchy. So in order to complete that particular project successfully, we will be using one hierarchy, one step-by-step process we'll be using, right? Similar to that, whatever the data science that you are working on, irrespective of any domain it is, whether it is healthcare domain or whether it is agriculture or banking or insurance, irrespective of any domain, we will be applying the CRISP-ML methodology. That is the reason it is called as cross-industry. Irrespective of any domain, we will be applying the same CRISP-ML format. In order to improve the accuracy of the model, or in order to follow that hierarchy, we will be using CRISP-ML format. So what are the CRISP-ML methodology? What are the phases we will be having? Each phase, we have 6 phases. So what are those phases and what will be happening in very first phase and what happens in second phase, third phase, fourth, fifth, sixth, something like that. We have 6 phases. What we will be doing in each phase, we will be discussing in CRISP-ML methodology in detail. And then once it is done, we will be having exploratory data analysis and pre-processing. Exploratory data analysis, name itself saying that exploring the data. exploring the data. So whatever the domain that you're taking, let's say we are taking the banking and insurance analytics. So there are so many use cases we'll be having when it comes to bank and insurances. So first what we'll be doing, whatever the data that we are getting. So raw form of the data will be having so many anomalies. A raw form means directly, whatever the data that is collected from the source, directly we are taking. In that case, we might be having so many missing values. Let's say if you are doing some survey, if you are conducting some survey, in that case, you might not be getting all the features that you are mentioned. Let's say age, salary. Let's say you are collecting the weight as well. So everybody, like whoever you are going for that, whoever you are asking that details, in that case, they might not be comfortable sharing all the details. So in that case, we will be having that missing value, that is NA value. The value is not available. In that case, we have to process the data, we have to clean the data, or we have to impute data based on the requirement. So whatever the raw form of the data that we will be getting, so it is not a perfect, you will be having so many anomalies. Once the anomalies is clear, let data cleaning we will be calling it as data cleaning or data processing, or you can say pre-processing as well. So we will be doing the cleaning. When it comes to anomalies, we will be having so many missing values. That is one anomaly. Extreme values. We'll also call it as outliers. So it is also one anomaly. Duplicates. The same, the information is present again and again. Again, in that case also we will be calling it as anomaly. So like that, various anomalies will be having when it comes to raw data. So when you have anomalies in your data, you can't directly feed the data into the machine learning model. So it won't be able to accept that particular data. So what we have to do, we have to clean the data. So that is, we will be calling it as data pre-processing. Once the data pre-processing is done, we have to explore the data. So what exactly that features are, and how many, I mean, when you are exploring the data, we will be creating so many visualizations to come up, why we are creating all those, visualizations, so that we can come up with some insights. Data means you will be having some insights, right? That is the reason we will be doing the data analysis. So we will be going through the data, and with that, we will be coming up with some insights. For that, we need to do exploratory data analysis. Once it is done, we will be having data mining. So in data mining, we have two types. One is supervised. So you can say, you can call it as algorithms as well, unsupervised. So we have various, we have other types of algorithms as well, like semi-supervised. Also, we have one type, but mostly we are considering just two. One is supervised and one is unsupervised. So we will be discussing only two, supervised as well as unsupervised. So what exactly the supervised is? That is, we will be discussing in detail in data prime, but I'll be going through very briefly. So when you have data, let's say this is your data. So two data frames you'll be having. In one data frame, these are the x1, x2, x3. So let's consider these are the inputs, and I'll be having one output. Here, same x1, x2, x3, and x4. Here I don't have any output, only inputs I have. When you have, let's say, COVID data, let's consider the COVID data. Or we can, since we are discussing about the banking, and insurance analytics. In that case, you can take loan default as data. Loan default. So it is one of the use case. Let's say based on few features. So in order to tell that particular person gonna be a defaulter or not, what do you think? What kind of features we can use? Age, we can use. Salary, we can use. And experience, we can use. What kind of job he is doing, whether it is technical or non-technical. So that is also one important feature in order to say that he is going to default the loan or not. Like that, we have various features. Let's consider, I'm considering here just three. Age I'm considering, salary I'm considering, and experience I'm considering. Let's say I have considered just three. Based on these features, I have to tell whether that particular person going to default the loan or not. If let's say you have a historical data, and in that, based on these features only, we are able to predict that that particular person going to default or not. So if it is, if he or she, anyone, if they are going to default, in that case, we'll be calling it as yes. If not, in that case, not. So here, clearly we have an output. So this will be calling it as labeled data. In your data frame, if you have an output that is Y, in that case, we will be calling it as labeled data. If not, so the same features, experience I'm considering, age I'm considering, salary I'm considering, and whether that particular person, what else we have? Outstanding loans, if you have any outstanding loans or not. So like that, I will be considering different categories. So whatever the categories will be having, for that, we don't have any output. Are we saying here, do we have any output saying that, yeah, this is the data, based on this, we can say that whether that particular person will default or not. So do we have any outputs? No. Based on these data, we will be coming up with some similarities. So it's not just one input, right? Like hundreds of thousands of inputs we'll be having. So based on those inputs, we'll try to segregate the data. So maybe it is 2 types, 3 types, 4 types, 5 types, any number of types. Based on the data, we will try to segregate. So here we will be using unsupervised learning. So here we will be using supervised. I hope it is clear. Supervised and unsupervised. When you have a labeled data in your data frame, when you have a labeled, that is output column, you can say. Labeled data, in that case, we will be going with supervised. If it is unlabeled data, you don't have any output, in that case, we will be going with unsupervised. So these are supervised as well as unsupervised. So these comes under data mining. And that day we will be discussing about the k-means algorithm. We'll take it is part of the unsupervised, one of the unsupervised algorithm and very frequently used algorithm. We'll take one use case scenario. Like what exactly the k-means algorithm is. What exactly the k-means algorithm is and how we can apply this k-means algorithm in real time. How can we apply that k-means algorithm in real time? We'll try to analyze on that day. We'll try to understand what is algorithm, how it will be working in the back end, and we'll try to use one use case scenario, that is real-time scenario, and we'll try to do the unsupervised learning on that particular data. Once it is done, we will be having k nearest neighbor. So we have just discussed, right, what is the supervised and what is unsupervised. It is a part of supervised algorithm. So this is, we'll be calling it as k nearest neighbor. It is one of the supervised model. We'll try to understand what exactly the KNN is and how this algorithms will be working. Since it is a supervised, how it will be classifying those into different classes. So we'll try to understand that algorithm, and same we'll be using one use case. Various use cases we'll be having. We'll try to take one use case that is applicable in real time and real life, and we'll try to do the classification. So it is one of the supervised. And then we have decision tree. So decision tree is also part of the supervised algorithm, and we can use this k nearest neighbor and decision tree for both. K nearest neighbor you can use for the regression, and decision tree, in that we will be having random forest. So random forest is based on decision tree only. In that case, we will be using that for the regression as well. And we'll try to understand how the decision tree is working. So what are the components we'll be having in the decision tree. So all those things we'll try to understand, and then we'll be using one use case scenario, and we'll see how can it will classify classes into different classes. So that we will see, and then we'll be having the regression. So we need to understand the difference between the classification as well as regression. What is the main difference between the classification and regression? We'll try to understand in the upcoming sessions, and it is also one of the supervised algorithm. We will be discussing how linear regression will be working, and how can we apply that linear regression in real time. That is also we will see. And finally, and it is not the final, we will be adding the text mining as well in upcoming classes. Multi-layer perceptron. So you might be heard about AI. So in that we will be using multi-layer perceptrons, neurons we can say. We will see how the multi-layer perceptron will be working and how it will be generating the output. Since it is a black box techniques, we won't be able to understand what exactly happening inside that algorithm, but we'll see how it is generating the output and how accurate that particular output is, and we'll try to understand how the multi-layer perceptron will be working. So these are the agenda for this domain analytics program. We'll go through one by one, each topic one by one in detail. So today we'll be discussing about applications. So what are the applications we'll be having? Machine learning applications, obviously, AI and machine learning. So we need to understand the difference between the AI and machine learning as well. So we'll go through that very briefly, and then we'll see what are the applications of AI or ML when it comes to banking and insurance, and how it will be revolutionize the banking industry and insurance industry. We'll go through. Yeah, without wasting any time, let's get into the session. So these are the agenda of the domain analytics program. Yeah, what are the analytics? Why do we need it? And why insurance analytics? Why in insurance? So I have taken the banking only, why not others? Yeah, we can absolutely, apply the same analytics on each and every domain. That is the reason we have come up with over 70 plus domains. We have come up with over 70 plus domains. All the domains will be completed. And if you want, you can simply go to the YouTube channel, whichever the domain that you belong to. Simply search and add 360DG at the end. You can easily able to avail those videos. So those are present in our 360DG playlist. So why insurance? How the data science, or you can say machine learning or AI, will be helpful when it comes to insurance, and how it will be helpful in banking. So those things we'll try to understand. Insurance plans will help you to pay. So what exactly the insurance is? Let's say we'll be having various insurances, right? Bank insurance, bike insurance will be having, and health insurance will be having. Health insurance will be having nowadays everything. Phone, if you are buying some expensive phone, in that case, for that also we will be having insurance. In that case, they will be generating a lot of data. So in order to process all those things, we need to have some data analyst who can process the data, who can understand that particular data, and who can come up with the insights. So if you are familiar with that particular domain, in that case, you can come up with the inferences way easily compared to the people who don't have an understanding about that particular domain. Obviously, right? You need to understand those terminologies. Let's say if you are from the insurance, that you have extensively worked on the insurance, let's say at least 6 months to 2 years of experience you have. In that case, you can able to understand those terminologies way better compared to the person who is very new, even though he has machine learning experience, data science experience, and he doesn't have any understanding about that particular domain. Let's say it is insurance domain. In that case, even though he has a good knowledge of machine learning and he don't know what are those terms meaning. So we'll be having so many new terms, different terms, right, when it comes to insurance. If he doesn't know what are those terms means, in that case, he won't be able to understand the data, and he won't be able to come up with inferences. But if you have an understanding about the domain, the terminologies, and in addition to that, if you have a good understanding about data analytics, in that case, you can easily come up with the inferences. So that is a one advantage we'll be having. Like if you are good at machine learning, in that case, you have to learn domain. If you have a domain knowledge, in that case, you have to learn the machine learning. So it is either way. So what exactly the insurance that we are discussing? Insurance plans will help you pay for medical emergencies and hospitalizations and contraction of any illness. Nowadays, you can see because of the COVID, insurance policies reached highest surge ever because of COVID. So we don't know when we will be getting infected with the COVID. If you are getting infected with the COVID, in that case, huge amount you need to pay. Huge amount you need to pay for the hospitals. To avoid that, what people are doing, they are going with insurances so that we can save a lot of money. Insurance can help you pay for medical emergencies. Obviously, if you are, if you have an insurance, in that case, you can easily able to escape from that particular huge amount. Hospitalization bills also they will be covering. If suddenly something happens, in that case, they will be giving assistance, right? So it is not like they are giving free. We are paying every month installments. Will be paying, right? So and medical care required in the future. Unforeseen something damages happening. Let's say if you are done insurance for the crop, and because of natural calamities, the whole crop is gone. In that case, you can apply for the insurance, saying that I have insured for the crop, and because of this natural calamity, the whole crop is gone. In that case, I can claim the insurance. So like that, we will be having so many ways. So many ways we can do the insurance. To process all these things, whom should I give? Whom should I sanction? So there are so many people who do fraud as well, right? If something, it is very common. So in that case, how can I analyze the data? Whatever the information they are giving, is it true or not? So like that, we will be having millions of people, right? Let's say one organization, let's say SBI, or we'll be having Apollo. Apollo Health Insurance, like that. We have various health insurance, right? For that, thousands, like millions of people will do insurance. So is it possible to go through each and every person record personally? So it is not possible. So we will be having some requirement. We will be having some, conditions. If they are satisfying those conditions or not, who will look into those? So it is not possible to look into those all these manually. That is the reason we are dependent on machine learning. So whatever the process, the hectic process will be having, right? So whole thing goes through machine learning. So for that, we will be feeding the large amount of data to train that machine learning model. Based on that, it will go through all the records that are coming. Like if someone is applying for the insurance claim, in that case, whatever the details that he is entering, it will simply go through the machine learning algorithm, and it will simply say that whether we have to pass that request or we have to block the request, whether whatever the request that is coming or insurance request, that is claim, you can say claim is coming, whether it is genuine or not. So you can simply train the machine learning model and you can deploy so that you can avoid so much time wastage. It is not possible to deploy one manual person to go through all the records. Instead, we'll be training one machine learning model and then we'll simply deploy it based on the previous history will be having. It will simply take decision. So for that, we will be using the machine learning so that we can easy the process, we can easily automate that whole process to avoid inconvenience for the customers. Like hundreds of thousands of people will be applying for the claim. So you can't go through each and every record, right? So you can simply deploy the machine learning model for that. So we have to go through the claims, right? So we can simply deploy the machine learning model. And here we'll be having the banking. So what are the use where exactly the machine learning algorithm or AI? So what exactly, where exactly we will be using the machine learning algorithm in banking? There are so many applications we'll be having when it comes to banking. So we have mentioned a few of them. Secure authentication using the image processing and visual cryptography. So we will be using AI in order to process whatever the person. Let's say you have deployed ATM one particular place. So whoever, if you want to give that access to the only one person. So whoever, even though you have given the credit card, you don't want other persons, whoever holding that credit card, those people only can able to withdraw money. Other than that, no other people able to withdraw the money. In that case, we can set up that algorithm, and in that case, whoever owner of that particular credit card, that particular person can only withdraw the money, and others cannot. So like that also we can do the algorithm. We can create one algorithm, something like that. Customer chain analysis. Customer churn analysis. So what is customer churn analysis? Let's say a bank, you have a bank and you have thousands of customers you will be having, right? Thousands of customers you will be having. And it is not like, see, one person created one account in your bank. Let's say it is XYZ bank. It is not compulsory that, right? He should be continue with your bank, continue with the bank with his, in his whole life. He should be should stick with that particular bank only. So we don't have any conditions for that, right? Whichever the bank he is liking, he will simply slide to that particular bank. If the services that are provided by the XYZ bank is good, in that case, he will be sticking with that particular bank. If he is not satisfied with that particular bank. In that case, what he will do? He'll simply switch to ABC. So it is one more bank, let's say. So until and unless the services that are offered by the XYZ, he is satisfied with those services, in that case he will stay. If he is not satisfied with the services, in that case we will simply switch to another. So it is pretty common, right? It's not just for the banking. So many YouTube subscribers, if you are liking that particular content, in that case he will be with you. If that content is not good, in that case, we'll simply unsubscribe and we will leave. It is not just about the banking. In each category, each domain, let's say manufacturing, if you are liking that one particular product, in that case, you'll keep using it. Next time you'll order the same. If not, if you are not liking that particular product, in that case, we can simply switch to other. Let's say you are using the like that. We have so many guys. Flipkart. If you like the services of Flipkart, in that case, you'll keep ordering your orders with the Flipkart only. And some way you felt that whatever the order they are delivering, they are taking too much time. So if you don't want, in that case, you can simply switch to some other Amazon. We have so many Snapdeal, something like that. So what is it? Customers churn out. So whoever customer is with you, they don't like your services and they are moving away from your services. So that we will be calling it as churn. People who are leaving that particular platform, we'll be calling it as churn. So when you have a churn, in that case, we can able to predict who's gonna churn. So we will be having historical data, right? So we'll be having so much historical data. Based on those historical data, we can able to predict like who can churn next. So we will be having patterns. We will be analyzing the patterns of each and every people. If they are following the same pattern as the historical data is having of churning, so we can say that yeah, these people might churn in next quarter or next year, something like that. We can predict. So if you can able to predict who is gonna churn out from that particular platform, in that case, what we can do, we can provide some additional support. We'll try to reach out to those customers and we'll ask and try to know what could be the reason behind it. So if we know those reasons, in that case, we can try to improve those qualities. We can try to improve the services so that we can avoid these churn. So we can avoid those churn. You can see that we will be calling it as customer churn analytics. And then we will be having fraud prevention. So let's say one bank. So you are the manager. So you are the manager of the bank. Some customer came to you and he said like, I want 10 lakh rupees loan. He said 10 lakh rupees loan. How can you sanction that amount? What are the things that you will be considering? You will be having huge, features you have to look into. Some conditions you will be having. Let's say, yeah, these are the let's say some random features I'll be taking. Not just this, we will be taking like tens of features, right, in order to sanction the loan. So let's say I have considered age and salary, have considered what kind of work he is doing, that I have considered, and place, or whether he has any collaterals or not, I have considered. Is he has own house or not, I have considered that. And experience, how much experience he will be having, that is also I have considered. Like that, tens of features will be having to consider. After considering all those things, then I will be making a decision whether that particular person gonna default the loan or not. So in order to come up with this, since it is output, we'll be having output. So we'll be doing the supervised learning. We'll be building a supervised model. Based on those historical data, we'll be building the model and we'll be supplying the new data to test how it is performing. If we know the output came out to be that he is going to be defaulter. So in that case, what we'll be doing, we'll simply reject the loan. We'll simply reject the loan. Fraud prevention. Fraud prevention. So he might be doing the fraud. So he might be just take the loan and he's not going to come back, or he's not never going to pay back. In that case, it is a huge loss. Huge loss for any organization, whether it is bank or any other organization. It is a huge loss. To avoid that, we need to have a fraud prevention. For that, we can build algorithm using the machine learning, or we can predict using the historical data. These are the persons can default the loan. So we can simply automate the whole process, verification process, the conditions that they have to go through, or they have to follow in order to sanction that particular loan. So that we can completely automate, and based on those features, whatever the feature, based on whatever the feature we have built a model, we'll supply those features of each and every person who applied for the loans, and based on those machine learning algorithm, whether we have to give loan or we simply reject the loan. So based on that, we'll give the loan or we'll simply reject the loan. If accuracy of that particular model is good, let's say 90%. In that case, 90% we are confident that whatever the model that we have built, whatever the output that we are getting is 90% accurate, means we are almost decreased 90% risk. Like let's say 100 people came. So among the 100 people are defaulters only, potential defaulters. I'm not saying exact, I mean defaulters, potential defaulters. When you are doing manually, in that case, you might have missed somebody. But if you have like thousands of entries of historical data, if you build a machine learning model on that, in that case, the same pattern, hundreds of thousands of entries will be having it. When there is one defaulter, he will be following any one of those patterns. So in that case, we can easily figure out that particular person. So even though it is 90% accuracy, you are able to classify that 90% people who are defaulters. So you had saved so much money, right? Instead of giving loan to all the people, all the 100 people, you have given to 10% people. Obviously, the loss that you have decreased from 100 to 10%. So like that, we will be building the model for the fraud prevention as well. We will be able to detect who's gonna do the fraud. Means who's gonna not gonna pay back once he got the loan. Anomaly detection, if something goes wrong, in that case also we can able to detect. So what exactly the anomaly detection? Something is fishy in your data. Whatever the data will be having, if something is not wrong, in that case we'll be calling it as anomaly, right? To find out that also, we can able to build a machine learning model. Credit scoring. So where exactly will be using the credit scoring? So in order to process the loan, we need to have a credit scoring, right? In order to build that credit scoring as well, we need to have a machine learning model. So we can able to do that credit scoring using a machine learning model. What is credit scoring? So previously, whether that particular person has taken any loan, if he has taken that particular loan, in that case, is he paid back in time? So what else he is having? Whether he has good salary, whether he has his own house, Similar to that, fraud prevention will be having, right? How can we, find out whether that particular person gonna, default the loan or not? Similar to that, we will be having based on the features, whatever the features will be having, we can do, figure it out what could be the credit score of that particular person as well. So how it will be helpful if you build credit scoring. In that case, it will definitely will help us out to define like whether it should give a loan or not to that particular person, right? So in that also we can able to use machine learning. Anti-money laundering. So to detect the anti-money laundering also we can use the machine learning model. So we have so many advanced machine learning models to predict those. And loan default prediction, obviously that is what we are talking about. Fraud prevention. How can we avoid the fraud prevention? When you know who's gonna default the loan. In that case, we are upfront. We are easily eliminating the people who are doing who gonna default the loan, right? So we can avoid the fraud prevention as well using the loan default and payment processing. So nowadays, previously we used to use so many records, the physical records I'm talking about, notes. In that we have tried to, we used to store all the data. So now you can't do it. There are so much data that is available, so you won't be able to do that all. So instead of that, we will be using machine learning and AI in order to store all the data and process the data. So in order to increase the processing time, we can go with the machine learning model. Fraud transaction detection. So it is one of the classic case to determine whether that particular case is a fraud or not. Let's say you have lost one credit card. So you know that, but other people don't, right? So we will be training the machine learning model. We have some, we will be having some, historical data. So how fraud transactions looking like? How much, how it will be happening? So like that, we have so many other, historical patterns. So based on those historical patterns, we will be building model saying that what could be the potential fraud transaction. Let's say in Hyderabad, you have done a transaction using your credit card at 9:05 a.m. let's say. Immediately in Chennai at 9:06 a.m. there is one more transaction with the same credit card. In that case, machine learning algorithm will flag saying that it could be a potential fraud transaction. Immediately they will give notification to the customer. Whoever holding that particular credit card, he will be notified saying that that could be a potential fraud transaction. Is that you who is doing the transaction or somebody else? In that case, if it is him, in that case he can say that yeah, it is me. Otherwise, if it is lost transaction, credit card, in that case immediately you can block those transactions. Like that, we can come up with one algorithm. So to detect that particular fraud transaction, we can come up with the one algorithm. Like that, we have various use cases, guys. And when it comes to banking, there are so many use cases that we can apply, where we can apply the machine learning or AI. So these are the few of the use cases when it comes to banking, and we'll try to understand other use cases as well. When it comes to insurance, so what exactly the AI? First, we'll try to understand difference between AI and ML, machine learning and AI. So what exactly the machine learning is? So we will be having historical data, guys. Historical data. What is insurance and banking analytics? Insurance analytics or banking analytics, any analytics is a process of collecting, analyzing, and extracting the relevant insights from the various data sources effectively manage risk to offer the best possible interest. So what we will be doing, we'll simply collect the data, we'll analyze the data. Once the data is analyzed, we'll try to come up with the inferences, various inferences we'll be having. When you analyze the data, then only we'll come up with the various insights. With those insights, we'll try to do the business decisions. Business decision. Let's say you have one loophole when it comes to bank. So there is one loophole. Everybody is taking the loan from that particular loophole, and even though you're not going to pay back, so there is no much thing that you can do from your bank side. So what, in that case, what you can do, when you go through the data, why people are, you will be getting, like, if most of the people know that particular loophole, in that case, everybody try to utilize that particular loophole, and they'll try to get money from the bank. So if you go through the data, in that case, you can find out these kind of anomalies. Yeah, why people are going through, why most number of people are applying loans from that particular route. What could be the issue? When you go through the data, in that case, you will be understanding what could be the loophole. If you come across that, that is an anomaly, right? So that is unusual things. I mean, if it is bank, if decision means all the decisions that we'll be taking from the higher position, all are not perfect, right? So you'll be having so many decisions that will be having loophole. If you go through the data, then only you'll come to know what could be the loophole in that particular data. So when you come across that, in that case, we can able to make a business decision. We'll be closing that particular policy, we'll be closing that particular accounts who's using that particular loophole, something like that. We can do so many business decisions. So what it is, any analytics, we will be, yeah, we'll discuss this, A and ML. So what we are doing, collecting the data, analyzing the data, that is exploratory data analysis. Using those, we will be coming up with various insights. Once we have done with the insights, on that we will be applying the business decisions. Finally, we are applying the business decisions. So this is what analytics means. Irrespective of any domain, we will be doing that. If you don't have any historical data, here historical data is everything else. Historical data is everything. If you don't have any historical data, there is no data science. There is no analytics. So we need to have some historical data so that we can process those data and we can come up with the insights and we can build some predictive models. So yeah, let me go through briefly what exactly the ML and what is AI. Machine learning. What is machine learning? Whatever the historical data we'll be having. Historical data. We'll be pre-processing that, clearing that historical data, and we are simply feeding that to the machine learning model. So what does machine learning model do? Machine learning contains so many algorithms and so many models we'll be having. Statistics, like we have discussed, right? Supervised, unsupervised, supervised, unsupervised, like that various models will be having. Once you feed this data to that machine learning model, it will go through all the data. Data means patterns. Let's say COVID data I'll be having, and it is the label data. Label data means output I have. Let's say I have taken, these are the inputs for COVID I have taken, whether that you have a cold or not, cough, body pain, or whether you have a smell or not. So based on these features, I will be deciding whether you have a COVID positive or not. So let's say all I have. In that case, I will be saying that you will be having COVID positive. It is not I am saying, Let's say I have a historical data like that. So one more, you have some else. In that case, I'll be saying the historical data is saying that negative. You're not having any, COVID. So like that, we have thousands of entries will be having. Like there are so many people who got infected, right? If you can, collect the data, in that case, thousands, millions of entries will be having. When you pass this data to the machine learning model, whenever you are passing that data to the machine learning model, what happens? Machine learning model goes through each and every data entry. So it will try to learn those patterns. If cough and cold and body ache and smell, if we are having all, in that case, it is a positive. That is one pattern. If we have cold and we don't have cough, and if you don't have body pain, in that case, and you don't have any smell, in that case, it might not be COVID. So in that case, I will be calling it as COVID negative. Like that, it is also one pattern. Like that, we have millions of patterns. Machine learning algorithms will go through all of those things and will try to learn those patterns. If it is learn that pattern, so let's say the machine learning model gone through all those patterns and it is performing really good. So what we'll be doing, we'll simply deploy the particular model. When you deploy, what happens now? Now we don't need to do any diagnosis. Manual diagnosis is not required. So whatever the symptoms you will be having, if you input those symptoms, whatever the machine learning model that we have built on, what are the features we have taken? Cold, cough, body pain, smell. These are the features I have taken, right? These are the not only feature, we have various other features, but I have taken, for the example, I have taken only these features. Based on these features, I am saying that particular person has a COVID or not. Once you deploy model, the same feature that you are giving as an input. So when you are giving these input, it has learned these many patterns. Based on this, it will come up with one logic. With that logic, if you are giving some inputs, in that case, it will simply say whether you have a COVID positive or negative. It will simply go through the data and it will give you the output. So what exactly we are doing here, using the machine learning model, we are creating one algorithm. We are creating one algorithm to decide whether that particular person has a COVID or not, COVID positive or COVID negative. So we are deciding whether that particular person has a COVID positive or COVID negative. Once it is known, we are simply deploying. This is machine learning model. The end product we are talking about, that we will be calling it as AI, artificial intelligence. So what exactly the artificial intelligence? Whatever the human work we will be having. So whatever the work that we are doing, we are simply automating it. That is only we will be calling it as artificial intelligence. That is only we will be correct. Whatever the human work, the manual work that we will be having, converting that into the automatic. Let's say AI. What is AI? Tesla car. That is the best example for AI. So previously, still yeah. What we will be doing? The whole thing, brakes that we have to handle. We have to drive the car. We have to handle that. You have to give the directions, and you have to take care of those roads. You have to look into all these things. Right? You are the one who's managing all these things, brakes, speed, and you're the one who's handling that. So everything you will be done. Right? Human used to do that. Yeah, we are the one who's handling. What we are trying to do in the automation, so all these controls we are giving to machine learning. All these controls we are giving to machine learning. So we will be training on each and every possibility. So it is not like everything is just like that. It is transformed to AI. So whatever the situation that come across, on that we will be training that machine learning model. Each and every aspect we are trying, we are training that particular machine learning model, and then once it is giving good results, in that case we will be deploying that particular model. Once it is deployed, the end product here will be called as Tesla car. So it is what? AI product. So whatever the machine learning model that we are building, the end product that we are creating, right, that only we will be calling it as AI. That is artificial intelligence. Yeah. So insurance analytics, what is happening? Collecting, analyzing, extracting the relevant insights from the various data sources and effectively manage risk of offer to best possible insurance contracts in the field such as health, life, property, casualty, among all the others. So when you analyze the data, when you have data, and when you have analyzed the data, in that case only we can able to give best insights or best outputs, we can say. So in insurance industry relies on historical data. Obviously, all the data that we are dealing with in data science, we will be relying on historical data. Assess the likelihood of potential risk occurring in the future, insurance risk analytics, insurance claim analysis, customer analytics, predictive analytics, and insurance industry. These are all the things that we will be doing using the machine learning. So all these things we can able to analyze using the machine learning when it comes to insurance. Design products based on the customer behavior. What it is? What exactly it is? Let's say you have thousands of customers. Let's say take one example. Let's say Apple company. Apple company we have. In that Apple company, we have millions of users. We have millions of users. So is it possible to go through each and every person review? Let's say what exactly that people are thinking about your mobile. Are they liking that particular mobile, or they are not liking the mobile? If they are liking that particular mobile, in that case, what feature they are liking? If they are not liking that particular mobile, what feature they didn't like it? So those things we have to look into. Which features they are not liking? So how can we? Is it possible to go through? Let's say we have over 80 million plus customers. Apple is having that many users with their Apple is having. Is it possible to go through each and every person and take a review? And based on that, we will be working on it. Again, call 80 million people. Is it possible? Absolutely not. It is not possible to go through each and every review of that particular person. So what we will be doing, we'll simply taking a sample. So we'll be taking few sample of data, and that sample we'll try to analyze using the NLP, natural language processing. When you analyze that data and using the sentiment analysis, that we'll be having in NLP, natural language processing. So using the sentiment analysis, you can come up with inferences, insights. So if you are going with the sentiment analysis, you will come across what people are talking about. We'll be having word cloud when it comes to sentiment analysis. If people are having positive opinion, in that case, word cloud will be full of positive words. If they are not liking the product, in that case, you will be having negative reviews. So word cloud will be having maximum negative reviews. So with that, we can come across what people are thinking about. It is not possible to go through each and every review. We'll simply deploy the NLP algorithm and we'll try to extract all those reviews and we'll try to pre-process those reviews, and among that, whichever the words are, data that represents sentiment, that it will filter out and it will give you the final result saying that, yeah, people are having the positive opinion about your product. If they are having positive opinion, which feature they have liked it. So in that case, we can improve other features. And if people are not liking, in that case, which feature they didn't like. So all these kinds of information that you can get using NLP. That is text mining. It is part of the text mining. We will be going through one use case scenario when it comes to text mining as well. We'll try to come up with one use case and we'll try to apply in the real time. So how can we say that whichever when it comes to insurance, so many people will be having reviews, right, on insurance as well, whether they are having positive opinion about that particular company or particular policy, if they are having one policy. So when it comes to insurance companies, there are so many policies will be having. For old people, will be having one policy. Adults in that case will be having one policy. For women, will be having one policy. When you have family, in that case, will be having one policy. If you have individual, in that case, will be having one policy. Various policies will be having. So what people thinking about it, and they will be having reviews, right? If you go through those reviews, and if those reviews are in thousands, it is not possible to go through each and every review and come up with the what kind of sentiment they are holding. Instead, we can deploy the machine learning model and we'll scrape out all the data and we can come up with the sentiment, whether it is positive sentiment or it is a secondary or it is a negative sentiment. Based on that, we can able to make a decision from our side, from customer side, and from the organization side as well. They can able to improve those where exactly they are doing some mistakes. They can come up with the some solutions. So like that, we can how this how it will be helpful. The machine learning algorithm will be helpful. Develop and enhance the customer experience. So when you are going through reviews, you will come across so many things people are concerned about. So in order to address, so it is not possible. Like when you have millions of users, it is not possible to address each and every person. You can't deploy person, human, in order to answer all those things. It is not possible. Instead, we will be having use cases. AI chatbots will be having chatbots. So whatever the queries they are having, we can create one frequently asked list, frequently asked questions, something like that we can create, and we can deploy the chatbots based on their queries. It can respond to those queries with high accuracy. High accuracy, on point. So instead of avoiding some mistakes, when you deploy the human, in that case, he might be doing some mistakes, but if you deploy a chatbot that is AI based, one product, if you deploy that, in that case, we can answer those queries very easily, and we can save a lot of time with that as well. And you can improve the risk management strategies and minimize the risk of insurance fraud. So there are so many, whether it is banking, same in banking. If you are taking the loan and if you are not able to pay back that loan, in that case, it will be a huge mistake, right? It will be a huge loss for the banking. You'll be happy. I mean, you are the one who took loan, right? But bankers, they have to suffer. So they will try to avoid these customers who can do the fraud. Similar to that, we'll be having in insurance also. There are so many things. There are so many loopholes. People find out and they'll come up with frauds. So in order to analyze that, also we can use insurance and banking analytics. There also we can use machine learning models. Improved personalization, same that we have discussed as insurance will be having, right? We will be analyzing their queries. With those queries, we'll be coming up with personalized, algorithm so that we can guide them better. Like chatbots, based on the frequently asked question, we will be coming up with a chatbot so that we can address their queries, reduce the cost. So obviously, when you deploy the machine learning models, in that case, we can reduce the cost that is happening when it comes to human resource, right? Let's say you have just for the query, customer query, you have deployed about 100 people. That whole 100 people work can be done by the single chatbot, right? Single chatbot. So we can save a lot of money when it comes to the queries as well. I mean, in order to answer those queries, we don't need this many people. Instead, we can deploy one chatbot based on their requirement. We can able to answer those questions. Accelerate decision making, even the things getting faster. I mean, let's say you have applied for the loan and it's been 15 days, 1 month, no reply. So what is that? They are manually going through all the documentation and all in order to approve it. So it will take a lot of time. So instead, if you build a machine learning model, and there are so many applicants, right? Like lakhs of people applying for the loan. So how much time it will be taking? So 1 year, 2 years, that many employees you won't be having, right? So each and everything manually going through that particular document, it is absolutely not possible. So that is the reason we can deploy the machine learning model. It will go through those and it will quickly give a decision saying that whether you can go with the loan to that particular person or you can deny the loan, so that we can make decision making faster. Improve fraud prevention, absolutely. If you can able to detect who's gonna do that default, in that case we can easily able to avoid those people and we can reject the loan to those people. Enhanced risk management is similar to the insurance. We will be having the same. Streamlined customer support. So chatbots that we are talking about, similar to that, and improve credit scoring. So if everything is going smooth in that, let's say one bank and there is one more bank. So the process that are in this bank is very speed. And here not having much. So we have applied for the one loan in just 1 or 2 days. They simply said that we can approve that loan or reject it. You have applied for the loan and it's been 15 to 20 days. No reply. In that case, definitely customer whoever applied for the loan, he will be get frustrated, right? He'll be annoyed. This much time you are making me wait and you are saying that rejected. So it is not a good way to deal with this particular situation. So you have to quickly answer them whether we can proceed with the loan or we will be not approving the loan to that particular person. So like that, we can improve the speed and the credit scoring of one particular organization. So these are the various benefits of machine learning we'll be having when it comes to banking. So these are the use cases we'll be having when it comes to banking. There are various other use cases also we'll be having. We will be discussing when we are doing the real-time use cases. And insurance analytics in various domains, we'll see how it will be helpful for us to make decisions. Yeah. Design customers. One of the use cases will be having design products based on the customer behavior. So companies are leveraging the see nowadays. Nowadays, we will be having. Nowadays, we will be having the data, huge data that is available. So many social media website, social media sites will be having. Websites will be having. Companies are going through this data. Companies are going through the data and they will try to extract personal information of one particular person. If you know that particular customer better, so what are their requirements? So they are coming with, they need one insurance. So what are the requirements? What kind of insurance they are going with? So if you know those particular customer better, in that case, we can customize. We can come up with a customized product. So in that case, what is the probability they can say no? Very low. If you don't know about that particular customer and randomly you are giving some policies. These are the policies we'll be having. Are you interested? Definitely he said, I'm not interested. But if you know about that particular customer a little more, in that case, we can customize that particular policy and you can say that, yeah, these are the policies we will be having in that case. If you know the data, if you know some information about that particular customer, in that case, you can come up with this kind of things. In that case, you won't be like probability of saying no is very less. Let's say one classic example I'll be having. Let's say I have building one product that is dog food. Dog food is my product. I'm manufacturing that particular product. So randomly, I have taken data from third party. I have taken the data from third party. In that case, I have got like 100 contacts. Random data. And there is a data that is scraped. That is scraped from social media. So what is that social media? So let's say they have collected the data, who were liking those pets, dog food. Pet food, you can say my company is pet food production company I'll be having. So whoever person who are liking those dog pictures and cat pictures, and they are very frequently watching, animal videos, and they are keep repeating those things. In that case, if I extract this data, let's say the same 100 people information I've extracted. Here also 100 people, here also 100. When you analyze the data, both data, if people are going through only repeated these, videos or images, and they are liking those images and videos, in that case, they might be having the pet, or they might be willing to buy a pet, or they might be simply liking that particular animals. So these are the probabilities we'll be having, right? If I take a data from here and take a data from here, same 100 people I'll be having, same 100 people I'll be having. If I call each and every person that is present in that, what is the probability that my products are getting sold? Here, what is the probability that my product is getting sold? So compared to this, we don't have any information about these particular peoples at all. So random people those are. Let's say if you are asking each and every person if you are calling each and every person and asking whether you are interested in buying that pet food, in that case you don't have any data in that. They might be, mostly probability is very low. If 100 people you have called, 1 or 2% they might be having the pets and they might buy it. 1 or 2, maximum 5%. So, but when you consider this data, so most all the people are somewhat interested in that particular pets only. Maybe most of the people are having the pets as well. So the probability of getting sold that pet food here a lot more compared to this. So a lot more compared to this. So in that case, what we can come across, when you know that people are somewhat interested, in that case you can customize that. So if you have a dog or cat, in that case we have those food as well. So in that case, the data that this is how the companies are leveraging those social media data. So just assume that this is a random data, same 100 people. So it is the data that is extracted from the social media based on the interests or likes of those people. Same 100 people. Here you will be having maximum probability that people might buy your product. I'm not saying 100% they will be buying. Maximum probability will be having here. The least probability will be having that they will be buying that particular product, because this data is very random and the data here is. So that is the reason, if you are extracting the data from web or some social media sites, in that case people somewhat related to that particular content. So in that case we can come up with customized and you can customize products, and we can market those products. In that case there will be a high probability they might be buying that particular product. So these are the advantages we'll be having when you know customer behavior. So like we have discussed earlier, same, develop and enhance the customer experience. With the efficient analysis of customer buying and behavioral data, insurance companies can respond to customer queries very instantly. So if you have the data very frequently, let's say insurance data, so you will be having public queries for insurance. What kind of questions they are asking frequently? Very frequently they will be asking some questions, right? What are those questions? So we will be creating one data frame of those questions. Whenever that particular question is coming up, we don't need some human to answer those questions, right? We can simply deploy on chatbot. We can simply deploy the chatbot. Based on that query, recommended answer will be sent immediately. So when the customer would be annoyed because we are not making any late, and process goes very smoothly when you deploy. So what we will be doing here, developing an enhanced customer experience. People would be annoyed with your business. I mean, whatever the thing that you are doing, because we are responding in very fast. So they don't need to go through that long wait and all. So we can enhance that customer experience. And using these machine learning models, obviously what we'll be doing, you can come up with new marketing strategies when you go through let's say insurance only. So you will be having historical data, right? Historical data. So many people who's buying insurances. When you go through those insurances, which policies are bought? Are bought more. What could be the reason behind it? The reason behind, if you analyze the data, when you collect the data and when you analyze the data, when in that case you can come across this, which policies are bought more, what could be the reason behind it, and why there is that much surge when it comes to those policies. If you know those, in that case you can add few more changes, and you can enhance those sales when it comes to that particular policy. Yeah, when you come across all those insights, in that case we can target the customers with the new improved policies, something like that we can do it. So this is one of the, yeah, irrespective of any domain, any product or anything, we will be having these frauds. Organization that exchanges money with the customers, services providers or vendors have always risk of exposure to the frauds and abuses. Obviously, it happens in any domain. So in order to avoid those, when it comes to banking, we have already we can deploy machine learning models that can easily able to figure out who are the customers who can pay back the loan and who are the customers who can default the loan. We can upfront, we can easily able to recognize those people, so we can reduce the risk. The same thing we can apply in the insurance as well. We can analyze whoever claiming that particular insurance based on the history. We can able to detect that is it fraud claim or genuine claim. So for that also we can able to build algorithm based on the historical data. Yeah, one more use case we'll be having one thing that seriously deserves special attention. Let's say healthcare. Healthcare insurance also will be having it. So in order to claim healthcare, so if it is an accident, in that case, you will be getting high priority. If it is accident, if you show them proofs, in that case, immediately that claim will be approved. When it is accident. So it is not mostly all the policies will be, insurance will be based on the accidents only, that will be approved. So if you have some other accidents, other than the accidents, if you have TB, and if you have some other things to go through, in that case, what they will do, we'll be having some conditions, right? In order to claim that particular insurance, we have a conditions, like it's not just one or two, tens, 20s of 30s of, I mean, there are so many conditions we will be having. So is it possible to go through each and every condition? For human I'm talking about. Millions of people will be having who's who done the insurance, and while they will be claiming, like thousands of claims will come every single day. So is it possible to go through each and every claim? So it is not possible, right? So whenever some claim is coming, in that case they will be having one form, input form. So based on those, whatever the feature that we are giving to the customer, so based on those only we have already built a model. We will be building the model and we are deploying the environment. So whatever the inputs that we are giving, that he is giving, machine learning models simply process it. So it is not possible to go through each and every condition. Instead, machine learning models go through it, and based on that, whether we should approve that claim or reject that claim, machine learning model will decide So mostly in this, we will be using decision tree. Most of the time, we will be using decision tree because it is having the explainability. One person has done the insurance with your company. Let's say XYZ company, you have one person has done insurance with your company. Once he done insurance, if something goes wrong, in that case, he'll definitely claim. I have done the insurance with you, and there is something, something unfortunate happened. I want to claim. So, in order to claim those, they have to meet some requirements, some conditions you have already given when you have taken that particular person has taken the insurance. Those conditions, it is not possible to go through by one person. Like you can go through for one person, but we have thousands of claims. In that case, you can't go through, right? We will be deploying the machine learning model, that to decision tree. Why we are using the decision tree, that I'll explain. So the same features, whatever the features that that person is doing the inputs, or inputting, or you can simply giving as inputs. So on that only we will be building the model. Once it is done, and if you are deploying some deploying that particular machine learning algorithm and with some accuracy, let's say AI model that you have deployed, or neural networks. AI model means end product only will be calling it as AI, right? Neural networks, that is MLP, multi-layer perceptron you have deployed. It might be having good accuracy, like 95% accuracy you got. And that person is not eligible. So AI model has rejected his claim. AI model has rejected his claim. So that particular person definitely come back to you and you will ask, why? Why did you reject? Why did you reject my claim? So what is the reason behind it? So you can't simply say that because AI model rejected it, so that have rejected your claim. So it is not a good answer to give, because they will be annoyed just because of some machine told you that my claim is a fraud. You have simply rejected it. So instead, we will be using decision tree model. So what exactly the decision tree is? It will be having explainability. So whatever the conditions that you are considering, are they following those conditions or not? Which condition they haven't followed? So each and everything, it will be giving you the list. So we can show to that particular customer, you are not meeting this criteria. That is the reason your insurance claim has been disapproved. Like that, we can come up with answers. So for that, we will be using the decision tree. So it is one of the not one of the best algorithm when it comes to explainability. So we will be taking the use case for that as well, and we'll try to understand how we can use in real time using the decision tree. So when it comes to market, so how insurance market will be in future? So they have global insurance analytics market size is expected to grow USD 8.8 billions in 2020 and USD 20.6 billions by 2026. So this much scope will be having when you have this much scope. In that case, demand for data analytics and demand for the people who are in this particular domain, insurance and banking, it automatically increase. So when it is just 8.8 billion, and it's 2020, it will become how much it is? 200 plus growth rate in just 5 years. In that case, demand for data science and the data analytics people who are particularly in the insurance and the banking, it will definitely increase. So, and several people, so they are trying to automate everything, and in order to increase the accuracy as well. So they are trying to move from the traditional calculation to the machine learning calculation in order to improve the accuracy and decrease the losses. So that is also one good sign for that for machine learning based jobs and the data analytics based jobs will be increasing tremendously when it comes to upcoming future. So why insurance or why means? So this because of this data. 2020 have about 8.8 and in 2026 it will become 20.6 billion. Just massive improvement on that gonna come in banking and insurance analytics scope, you can say. So this much scope we'll be having when it comes to this analytics, or you can say machine learning. So yeah, these are the applications, guys. When it comes to banking and insurance analytics, we have gone through very few. We have so many applications, but among that, we have gone through very few. So I hope you guys have understood what exactly the machine learning is and what is AI is, and how can we apply this machine learning and AI when it comes to insurance and banking. How it will be useful. How can we improve? What are the applications we'll be having? So all those things I hope you guys have understood. And yeah, in next class we will be dealing with CRISP-MLQ, cross industry standard process machine learning, and quality assurance. The phases I have discussed it in the very first 5 minutes. So we will go through those phases in detail. How we can, what are the phases we'll be having? What will happen in each and every phase? So we'll try to discuss all those in the all those things in the next meeting, next class, guys. And yeah, that's it for today. And I hope you have learned something. And if you are interested in this, if you want to learn more, in that case, you can continue with this series. And if you want to learn other domains, in that case, you can go through 360DG. As I told you earlier, you can go through and you can find the playlist and you can watch it. And yeah, thank you for watching, guys, and thank you for joining for the session, and we'll see you in the next class. And until then, have a nice day.